Hi, everybody. Welcome, welcome, welcome to another live YouTube programming. We call this our YouTube spaceship here at the American Museum of Natural History. My name is Jackie Faherty, and I'm an astrophysicist at the museum working in the Department of Astrophysics. And I am so excited today to be able to work with a very, very special person who's going to take you through the content of today's program. Before I introduce her, I just want to say that we'll be watching the chat the whole time, both myself and our presenter, Marina. And so I can already see people telling us where they're from. Jenny, I see you tuning in from Lawrence. I saw somebody, maybe Michelle was tuning in from Scotland a minute ago. Shein, I think I see you from New York City. We're so excited to see so many people in here. Tell us where you're watching from. We're going to be taking your questions live as we fly through for this content of comets, all things comets. Today, I'm actually going to be your pilot, as well as a couple of sprinkled comments as we go through, flying this software that we call Open Space. It's a NASA-funded, all open source, so freely downloadable software that you can use yourself. And because this is NASA funded as well, our friends at NASA actually really want us to find out how you guys feel about this. So at the end of our presentation here, there'll be a link for a survey, and the first 30 people will get a free NASA sticker mailed to them, which is very exciting. But without further ado, let me introduce our speaker for today, Marina Gemma. And Marina is a grad student at the American Museum of Natural History, and she is going to be your content expert today. So I'll let Marina take it away from here. Go ahead, Marina.
Awesome. Thank you so much, Jackie. As Jackie said, my name is Marina Gemma. I'm a PhD student at Columbia University, but I do my research at the American Museum of Natural History. And I'm a planetary scientist, which means I study the different planetary bodies in our solar system. And my research in particular focuses on the objects we call small bodies in the solar system. And this includes asteroids and comets. So they're kind of like solar system siblings, but there's a few differences between them. And we'll get into that today because we are talking all about comets. So in my opinion, comets are one of the most spectacular celestial sights that you could see from Earth. But today we're going to leave Earth and actually go check these out up close. And what's really great about the visualization program we're using, OpenSpace, is that we can show you the journeys of comets. So where they're going, where they're coming from, and we'll be showing you their orbits, so the paths that they take around the sun, because a lot of comets take pretty unusual voyages through the solar system. So we started out hovering over New York City. Jackie had us right near the American Museum of Natural History, our home institution. And as she's pulling away, you can kind of see the Finger Lakes, the Great Lakes right there. And as we're zooming away from Earth, we're going to start with a little introduction to the structure of the solar system. So before we dig deep into the details of comets, we wanted to give you an idea of where they came from and why you can see them from Earth. And to do that, we need to know how the solar system works. And here, we're going to zoom out and get a good look at the structure of the inner solar system first. And these different colored lines that you're seeing represent the orbits of the different planets. So these different colors each represent a different planet, and that's the paths that they're taking around the sun. So when Jackie pulls out, we'll look at the 4 inner planets. So the planet closest to the sun, of course, is Mercury, followed by Venus. Venus has that orange orbit. Earth is in blue, and Mars is in red. And beyond Mars, there's a gap between it and the next planet, Jupiter. And in this gap is the asteroid belt. So asteroids are rocky bodies left over from the time of planet formation in the early solar system. And these are the objects that I study, but we won't be focusing on them today. So if you want to learn more about asteroids, you can actually tune in to a previous field trip we did where you can learn all about these rocky bodies. So the asteroid belt is important because it marks a compositional divide in our solar system. So the rocky inner solar system, then you have the asteroid belt, and then the icy outer solar system. So the 4 inner planets between the sun and the asteroid belt are known as the terrestrial planets. And these are mostly made up of rock and metal, whereas the 4 outer planets are mostly made up of gas and ice. So as Jackie moves us further away, you'll see these 4 outer planets come into view. Jupiter, the biggest planet in our solar system, has that pinkish orbit that you're kind of seeing right now, followed by Saturn in yellow. And these 2 planets are known as the gas giants because they're essentially just really big balls of gas in our solar system. And following Saturn is Uranus. And finally, we have the planet Neptune. That's that dark blue orbit that you see over at the edge.
Marina, before we keep going, I want to give people some distances here because we're pretty far away now from the sun. And to give you an idea, the distance between the Earth and the sun is, we don't even talk about it in miles really because it's so far. We say it in light travel time. And the Earth right now is 8 light minutes away from the sun. And we are currently orbiting 2.8, 2.5 or so, maybe almost 3 light hours away from the sun at this distance.
Yeah, absolutely. And distance is important when we're talking about the solar system. So another way to think of that is that Neptune is about 30 times as far from the sun as Earth is. So even though, we're at the last planet in our solar system, we're still really far away. But you might be surprised to hear that the solar system doesn't end with Neptune. So now that we've gone through all the planets, you might be thinking, what does this have to do with comets, right? So comets actually originate way out here in the solar system. And comets are made up of icy material, so ices, gases, dust. They're often called dirty snowballs because they're really a ball of ice with some dirt on it and looks like a dirty snowball. You can have water ice, methane ice, carbon dioxide ice, just a lot of ices. And the reason that we took you through the structure of the solar system is we really wanted to emphasize the differences in composition as you get further away from the sun. And so asteroids and comets are comparable to each other in the sense that they're both small bodies left over from the time of solar system formation. But the main difference between them is their composition, which reflects where they come from. So since gases and ices are more abundant in the outer solar system, that's what comets are made of.
Marina, real quick, we've got some questions coming in from Veronica, who's 9 years old, and we want to make sure we get things straight with her too. So she's asking about how much is a light minute, since that's the description of how far away the Earth is from the sun. And just for people as reference, light takes 186,000, it moves at 186,000 miles a second. So use that as your speed limit, Veronica.
Awesome. Thank you, Jackie. I think now maybe we could turn on the trans-Neptunian objects. What do you think?
I'm going to turn them on, and we're going to just tell people that this is a very high-end software, and sometimes these objects may cause it to look a little bit funny. It's perfect.
Wow. So beyond Neptune, we have what we call the Kuiper belt, which is similar to the asteroid belt in the sense that it contains a lot of small bodies. But remember, what they're made of is different. So out here, we have icy bodies rather than mostly rocky bodies. And the Kuiper belt is also way more massive than the asteroid belt. It's almost 20 times as wide and many, many times more massive. So it means it contains more material than the asteroid belt does. So Jackie has turned on here what we call the trans-Neptunian objects. And this is a small subset of objects that are in the Kuiper belt. And this is the data set that we have in open space, and we wanted to show you. So they're not all comets, but most of them are. And these objects cross the orbit of Neptune, which is why they're called trans-Neptunian objects. And in this data set, there's also multiple dwarf planets, including Pluto, which is a dwarf planet, not a full planet. Sorry, anybody who disagrees. But there's also a lot of what we call those dirty snowballs, the comets. So
just quick on that, Marina, because so people might be able to see that there is a green line in here, and that is the orbit of Pluto that I've made a little bit bigger for you. And people actually used to say before, when this debate was getting hot, if Pluto actually got close to the sun, it would grow a tail as it would start burning up. We know a lot more about Pluto right now, but Pluto's in that place where you get a lot of these icy snowballs, and it's got a lot of those features as well.
yeah. And we actually have a great question in the chat from Laura asking, what are the blue dashes instead of blue lines? So that's a great thing to point out. So the dashes and the lines, these all represent trans-Neptunian objects, but the shorter lines, so I think what you're talking about, the dashes, that just means that those objects have a shorter orbit, and the objects with a much longer line just have a longer orbit. So that's what those are. But I think, Jackie, why don't we zoom out some more? Because we're still not at the edge of the solar system.
As we go out to Marina, it looks like Jericho, age 9, is really wondering how many comets there are. So we might want to remind him.
Great question. So this is a little bit hard to answer. So there are, I think, 6,000 or 7,000 confirmed comets. So objects that we know are comets and that we've been able to observe. But so the Kuiper belt and now what Jackie's turning on, the Oort cloud, they're so far away and they're so massive, and we think there are possibly billions of comets in these regions, but we haven't confirmed that. So even though we know there's like about 1 million asteroids or so, there's only a couple thousand confirmed comets. But as we continue to study these and we continue to look for more, I think that number will go up. So where Jackie's brought us now is to another important region in the solar system. This is the Oort cloud. And the Oort cloud is a sphere of material that encapsulates the whole solar system. And like the Kuiper belt, is a source of comets. So these comets are what we call long period comets. They take a really long time to make their lap around the sun. So the edge of the Oort cloud is actually 200,000 times as far away from the sun as Earth is. So Neptune, remember, we said was 30 times as far from the sun as Earth. And the edge of this Oort cloud, this pink sphere that you're seeing visualized here, is 200,000 times as far, which is crazy because that's actually a third of the way to the closest star to our solar system, Proxima Centauri. And I think, yep, Jackie has the constellation lines turned on. So in the background, you can see these lines connecting stars, denoting the constellations that we all know. And in the lower right here, you can actually see Proxima Centauri. And look how close that is to the Oort cloud.
Yeah.
Jackie, what distance are we at right now?
Right now, we're just outside of the Oort sphere, so we're about, I would say, 2 light years away. So maybe we're about half of the distance to the Proxima Centauri, Alpha Centauri triple system there. And this area here, I also just want to throw back here, Marina, because we've got a question here about where Michelle was reiterating the question of where comets come from. And Marina was just explaining they come from, in part, this area here, this whole surrounding area. So we're out here at about 2 light years away. The star that I've got kind of orbiting over here that you can see coming off the closest to us in these constellation lines, that's the Alpha Centauri, Proxima Centauri triple system in there.
Awesome. So again, just as a reminder for anybody who might have joined, my name is Marina Gemma. Our pilot here is Jackie Faherty, and we're taking you guys on a tour of comets in the solar system. But you guys might, uh-oh. Okay, so we're actually gonna jump away from open space for a second here while Jackie starts up our next section. And we're going to talk about a comet that you guys might have seen in the news recently, Comet NEOWISE. So I want to take a poll in the chat. Like, let me know. Have you guys heard of this comet, Comet NEOWISE? Have you seen it? Oh, maybe? Okay. So this comet put on a spectacular show this summer. We're getting some yeses, people saying they've seen it. It made its closest approach to the sun in early July, but it was only discovered in March 2020 by the NEOWISE mission, which is an infrared space telescope. And Comet NEOWISE is named for the NEOWISE mission that discovered it. And it has a really long period orbit, which is probably thousands of years. We're not exactly sure, but that's what scientists have estimated. And it was all over the news. It was bright enough. If you really looked, you could see it with your naked eye, but you could definitely see it better with some binoculars. And what Jackie has shown on the screen here is actually a photo that I took of Comet NEOWISE. And I was so excited because I had never seen a comet before in my life, but I really wanted to see this one. And this isn't even using a telescope. This is just taking a normal camera. And I snapped a photo of Comet NEOWISE outside my house.
Marina, I want to just to throw in here that I think Comet NEOWISE, for those that weren't paying as much attention in social media, I think it's the social media comet of our lifetimes. It's really the first time we've had this like Instagram, Snapchat, Facebook, Twitter, all of that ongoing, and people were posting pictures every night. So if you follow space news, I don't think there's any way that your feed wasn't filled with images like this, that everybody was having FOMO, fear of missing out, wanting to get the picture. And I was around and paying attention for the one prior to this, Hale-Bopp, that was really popular. But nothing like NEOWISE. We didn't have the kind of ways of sharing images like we do now.
Absolutely, yeah. And like I said, I took this image because I was so inspired seeing all of the images all over the news, like you said, social media. But I definitely think my photo isn't as good as some of the more professional ones, which if we want to bring that up, Jackie, I can talk a bit more about what you're seeing here. So you might recognize this image from the promotional photo that we used for this field trip. And this, I believe, was shot in like Joshua Tree National Park. And it's really, really cool because you can see almost the entire tail of this comet. And it's actually, if you look really closely, split into two. You see there's kind of a barrier between like this skinny little line on the left and the more misty, like foggier trail on the right. And that is actually just a result of the comet's path. So the line on the left points directly to the sun in relation to where the comet is. And the trail on the right is this dust trail that you're seeing. And so we actually haven't talked about why comets have these trails yet. So like we said, and like we found out when we went out to the Oort cloud, comets come from this material that's like really icy, lots of volatile material. But as comets travel to the inner solar system, where the sun is, right, they get heated up because it's warmer in the inner solar system than it is in the far reaches of the outer solar system where these comets come from. And so as the comet passes by the sun, the ices transform into gases and pull away dust particles with it. And that's what creates this tail that you're seeing. And it makes for spectacular images like this.
And Marina, I should say that comets, before people knew what they were, so go back a couple thousand years where before the telescope, before we really understood stars were stars and planets were planets, comets were looked at as interesting and mysterious objects and omens of sorts, that they might mean something. Now, of course, we don't have that. We know what they are now, icy snowballs coming in from the outer solar system. But at the same level, I found it interesting that we've always used comets as markers for things that are important over time. And at this point, 2020 has been a pretty bizarre year. And we've got Comet NEOWISE here to give us a little bit of a perspective. And we're back in business with open space, so why don't we carry on? We've moved back into the inner solar system here, and I can
Amazing.
turn on some more objects for you, Marina.
Cool. Why don't we look at comet groups, Jackie? How about that?
Let's do that. Which ones should we start with?
Let's look at the Jupiter family comets. So we're going to turn on, like we mentioned, these different comet groups. And you'll notice that they're colored differently, but that's just to distinguish them from one another. And it really only means that they have different orbital properties. So the Jupiter family comets that we're looking at now in green are short period comets, which means they complete one trip around the sun in about 20 years or less. And they're named the Jupiter family comets because the gravitational influence of Jupiter is what determines their orbit. So again, when we're talking about comets, I'm using this word or this term orbital period a lot. And just, as a reminder, the orbital period of Earth is 1 year. It takes 1 year for us to make one lap around the sun. And so when we're talking about the orbital periods of comets, if it takes them, 20 years to go around the sun, then that's the orbital period. So next up, we're going to look at the Halley type comets. And these are named after Halley's Comet, which is, I think, probably the most famous comet. Would you agree, Jackie?
Yeah, I would say. I mean, we could throw this to the chat, too. Why don't you guys tell us what you guys think is the most famous comet, or the most famous comet, and for disclosure, tell us your age as you say it. Because Halley's Comet was, some of us weren't born when the last time it came around, right, Marina?
I'm included in that group, Jackie. Yes. So Halley's Comet, I think, last passed by in 1986, and unfortunately, I was not alive to see it. But it's coming back in 2061, so hopefully, I can take a look at it then. So these Halley type comets have slightly longer orbital periods, so anywhere between 20 and 200 years. And they're often kind of pinballed around by the giant planets in our solar system. And the last group we're going to show you are the Encke type comets. And these comets have orbits that bring them really close into the sun, and they spend their entire orbit interior to Jupiter. So these are really short period comets.
I'll just say, Marina, I like what we're getting in the chat, as people are definitely justifying the comet by their age. We're certainly seeing some Halley's Comet fans in here.
Awesome. Yeah. Hale Bop. Bella remembers that one very clearly. Jacqueline. Oh, awesome. I would have liked to see that one. I was alive for that one, but I guess maybe I was just too young to remember. So now that we know where comets come from, we're kind of going to move closer back into Earth. And we're going to think about how we see these cometary objects from Earth. So like we've mentioned before, comets go on this crazy journey throughout the solar system. And as they're thrown around by their interactions with other bodies, they can actually be kind of slingshotted towards Earth and pass by Earth. So this means they often cross Earth's orbit. And when that happens, we get a really, really spectacular show.
Marina, I just want to make sure people know, I just turned on one specifically that you're going to talk about. So that blue line that people see now is the orbit of a special comet. And then I'll let you take it from there.
Fantastic, Jackie. Thank you. So she's turned on the orbit of Comet Swift-Tuttle. And Comet Swift-Tuttle most recently passed by in 1992. And it's actually the reason why we have the Perseid meteor shower. And this meteor shower peaked last week. And some of you might have seen it. Let us know in the chat if you did. This is probably one of the most famous meteor showers of the year. But the comet tail, right, with all that gas and dust, I've merged those two words, gas and dust, the comet kind of leaves that like breadcrumbs. And if it passes through Earth's orbit, it leaves these materials, and eventually Earth will pass through them. And these materials, these little dust particles, go through Earth's atmosphere and become the meteors that we see in the meteor shower. So the Perseids are actually not named after the comet they come from. They're named after the constellation they appear to come from. So when we're standing on Earth, the Perseid meteor shower looks like it's coming from the constellation Perseus, and that's where it gets its name.
I just want to tell people I was moving time backwards because we had the time set to today's date, but the peak of the Perseids, if you were paying attention, was last week, and I've set it to August 12th, and you can see this is when the Earth was crossing the path. The dark blue one is the Earth's orbit, and that light blue one is the orbit of Comet Swift-Tuttle, where it leaves behind little, like Marina said, I liked your line, Marina, about crumbs, like little crumbs that you would leave on a trail, and that when we go through, it's kind of like a crash between the Earth's atmosphere and those tiny little crumbs.
It is. And these tiny little crumbs, I really do want to emphasize how tiny they are. So they're, on the order of sizes of like sesame seeds. So these meteors that you see flashing across the sky, they aren't, big rocks. They're these tiny, tiny particles that create an amazing show. So I want to know, we see Bob said he saw 3 Perseids, 2 at a watch party. Anybody else? It was a really, really cool experience to see the Perseid meteor shower. I saw it last week. I loved it.
I think we're getting close to the end. We should definitely show the showstopper stuff, Marina.
We should, yes. So we've been talking a lot about comet orbits and their trails and tails, but what about looking at comets up close? That's what we're going to do next. And so Jackie's bringing up this image sequence that is showing Comet 67P. So this comet was actually the target of a mission that the European Space Agency sent in the early 2000s. And it is a Jupiter family comet. Remember, this is one of the groups we looked at earlier. And what you're looking at is a 3-dimensional model of Comet 67P in the center there, with 2-dimensional images of the comet that Rosetta, the spacecraft, took projected onto it. And this is one of the really great strengths of OpenSpace, the software that we're using, in that we can take the camera view from the spacecraft and combine it with a different data set, this 3D model, and visualize what this spacecraft was seeing. And because this is real data, we can fast forward or rewind through all of the different data that we have in OpenSpace. And this allows us to see how these different objects change through time. So these white lines that you're seeing here, that's the camera view. And the green line that you're seeing, that's the orbital trail of Comet 67P. But what I really want you to look for is on the right side of these images. If you look really closely, you can kind of see this like misty area coming off of the comet. That's its tail. And what I love about these images is that you can tell that the gas and the dust that's making that little misty, foggy area is coming off of the side that's illuminated by the sun. So you have to have the sun heating up the comet to get this tail. And that's exactly what we're seeing in these images. So there's a couple interesting discoveries that the Rosetta mission made. And one of them is that they think Rosetta used to be 2 separate comets. Because if you looked closely at it, it kind of looked like a dumbbell, like 2 different objects stuck together. And they witnessed crazy things on this comet surface. They saw a landslide. They found a cliff that was 3,000 feet tall on the surface of this comet, which I will say is only about 2 miles wide, so it's not very big. But this mission was so transformative for our understanding of comets and was a really, really cool source of information and visualization, obviously, for OpenSpace.
Marina, I had shifted back over to OpenSpace, but we just got a great question from Tara about how big was Comet 67P. And
so it's about two and a half miles, I think, on its longest axis, which I will say, I think NEOWISE is actually a bit bigger than that. I think NEOWISE is on the order of 3 miles or so. So Comet 67P, yeah, I was at 2.5 miles, I think. But to have a 3,000-foot cliff on a 2.5 mile object is quite impressive.
That is very, very impressive. Very impressive.
Exactly. So let's see, what should we look at next, Jackie?
I think we're on our closer, which I've got us set back onto open space, and I think we should talk about the visitors from other solar systems, Marina.
Let's do it. So we've talked a lot about the comets in our own solar system, but one of the most exciting discoveries, I think, in recent years, again, this is my opinion, but is the detection of interstellar objects. So these are objects not from our solar system, right? From even outside the Oort cloud that we showed you guys earlier. And Jackie is going to show us the orbits of 2 interstellar objects that were just discovered in 2019, so just last year. And you'll see their orbits come up in yellow. One of these is Oumuamua, which was the first interstellar object discovered.
I just switched it, Marina, so that you're only looking at Oumuamua right now for those that are watching.
Perfect.
And then I'll put the second one on.
Yeah, so the yellow line that you're seeing now, like Jackie said, is Oumuamua. And the second line that she's going to turn on is Borisov. And what's cool about Borisov is that we were actually able to confirm that it's an interstellar comet. And the way we did that is by looking at its surface composition and comparing it to the surface compositions that we know from the comets in our solar system and objects in the Oort cloud. So when scientists realized that those look similar, we were able to determine then that Borisov was an interstellar comet. So, yeah, I think these are pretty darn cool.
I'm gonna switch to something, Marina, which will allow people to see the discoveries of these things. So I'm gonna change the date to 2013, and then I'm gonna turn time. I'm gonna increase time to months per second, and I'm gonna set it at 2 months a second. And I'm going to make sure we're focused on the sun, not the earth. And then when I put it on, what's really cool is you see the planets going around the sun, but you'll also see Oumuamua first and then Borisov second coming in, as that's what we have their dates trailed back to. But we found Oumuamua when it was not closest to Earth. It had actually gotten a little bit further away. Borisov was awesome because we caught it before closest approach, then it got closer, then we actually caught it going around the sun, which meant that we could see it breaking up, or at least there were bets about whether or not it was going to break up or not. So now,
yeah, and I think an important point to make too is, how do we actually know that these are interstellar objects? And the easiest way to know is to look at how fast they're going and what their orbits are. So these objects are going so fast that they can't be trapped by the sun, by the gravity of the sun. And, all the objects in our solar system are revolving around the sun and are obeying the laws of gravity around our sun. But these objects are just, going too fast and are on their paths. They're just blowing by the solar system and continuing on their merry way.
We have a great question in here from Tim Sherrill, which was NEOWISE known to be coming, or was it discovered as it approached? And it's another one we didn't know about it until NEOWISE found it. And then for those that were paying attention, there were 2 other comets that people were talking about back in maybe March or so, that there was hopes that they would become bright naked eye comets. There was one called Comet Atlas, and unfortunately, like comets are, they're erratic beasts. It petered out, and we didn't get a good show. NEOWISE turned out to be the real showstopper, and we kind of found it pretty close to when it became that exciting naked eye object.
Absolutely, just a couple months before.
Yeah.
And I think that's the second part of Tim's question is really a good one. Might it be that there are other hidden comets that we might not yet know about? And absolutely. So, like I mentioned earlier, we only have about 6 or 7 thousand confirmed comets, but we know that there are many, many more out in the Kuiper Belt, out in the Oort cloud. And because these objects are so small, it's really hard for our current technology to positively detect them when they're so far away. But if they come back into the inner solar system and we are able to see them with our telescopes, then our comet count will start to go up. Our confirmed comet count will start to go up. So I'm really excited not only to hopefully hear about new comets discovered from our solar system, but I do think there's also going to be a lot more interstellar visitors in the coming years once our technology improves.
I think that's also a good place to end our program, on that exciting note of what's to come in the future for comets from outside our solar system, Marina.
Absolutely. And I hope you guys enjoyed learning about comets today. I know we looked at a lot of orbits, but these are important things to remember when we're thinking about these small bodies. And if you're sad you missed the Perseid meteor shower last week, the good news is that there's actually more meteor showers coming up this year. There are ones in October, November, and December that you can look up. We'll put a link in the chat for you guys. And like Jackie said earlier, our friends at NASA are really interested in knowing what you thought about this program. So please fill out our survey at the end of the program. And again, the first 30 people to fill it out will be mailed a free NASA sticker in the mail. And we'll give you the link in the program, or the link in the chat as well, for the survey. So thank you so much for joining. Thank you to Jackie for being our amazing pilot. And we'll see you guys on the next field trip.
And just as a closer, next week at 1 p.m. on this YouTube spaceship, which will not be leaving Earth, we'll have a live stream about the last Pinta Island giant turtle, the Galapagos tortoise, called Lonesome George. If you visited the museum when we had Lonesome George, we taxidermied Lonesome George. It was amazing. And we'll have a live stream about that next week at 1 o'clock. So I hope you can join us. Thanks, everybody.
Thank you, guys.